the magnitude of a vector is the length of a direct route between 2 points. So here we've got a to b is -7, 2. This top number is a change in the x direction, and this bottom number is a change in the y direction. So from a to b we go -7, so that's 7 to the left, and then 2 in the y direction, 2 up. So to go from a to b, we go 7 to the left, and then 2 up. The magnitude of a to b, the exact magnitude of a to b, is the length of this line directly between a and b. To find it, to find the exact magnitude of AB, we can use Pythagoras. It's a right-angled triangle, and we're finding a missing length. We're finding the missing hypotenuse here. This word exact just means that our answer is going to be a surd, a square root number, not as a decimal. So let's find the hypotenuse using Pythagoras. Pythagoras' theorem says a squared plus b squared equals c squared, or equal the hypotenuse squared. At a and b are the two shorter sides, the 2 and the 7. So we've got 2 squared plus 7 squared equals h squared. We can use a calculator here, so we can do 2 squared plus 7 squared on the calculator. So 2 squared plus 7 squared is 53. So we can say h squared is 53. To get h by itself, we square root both sides. So h is the square root of 53, which is just root 53. That's our answer. Root 53 is the exact magnitude of a to b. Here's a question for you to try. So pause the video and give this a go. So we're told a to b this time is 3, -4. So to get from a to b, we go right 3, down 4. So a to b, we go 3 to the right and 4 down. But the question is, what's the magnitude? So what's the length of this line? So again, we're using Pythagoras. A squared plus b squared is equal to the hypotenuse squared. We're finding the hypotenuse. So we've got 3 squared plus 4 squared equals h squared. 3 squared, we can use the calculator, but 3 squared is 9 and 4 squared is 16. So 9 and 16 make 25. To get h by itself, we square root both sides. So h is 5. The magnitude here is 5. It didn't say exact in the question. That's because we don't have a surd as our answer. We've got an integer. We've got a number as our answer. This is a 3, 4, 5 triangle. It's a famous Pythagoras triple. Here's another example. We've been given a to b and b to c, and we need to find the exact magnitude of a to c. So firstly, we have to work out what a to c is, and then we'll find the magnitude using Pythagoras. We can find a to c by thinking of this as a triangle. So if we have a, b, and c, we can say a to c is the same as a to b and then b to c. So a to c is the same as a to b plus b to c. So a to b, if we go from a to b and then from b to c, that's the same as going from a to c. So that's how we're going to work out A to C. It's A to B plus B to C. It's these two added together. When we add vectors, we just add the X changes together and we add the Y changes together. So in the X direction, we went 7 left and 3 right. -7 plus 3 is -4. So in total, we go 4 left. And in the Y direction, we went 2 up, 7 down. 2 take away 7 is -5. So we went, in total, we went 5 down. So from A to C can be written as -4, 5, which is 4 left, 5 down. It doesn't really matter which way we're going. We've got two sides of the triangle, which are 4 and 5. And we need the hypotenuse. So we're working it out using Pythagoras. So we've got a squared plus b squared equals h squared. 4 squared plus 5 squared equals h squared. So 4 squared plus 5 squared is 41. So 41 equals h squared. Square root both sides. So h is the square root of 41. So the magnitude of A to C, the exact magnitude of A to C, is root 41. Here's a question for you to try. So pause the video and give this a go. So again, we've been given A to B and B to C, but we want A to C. So A to C is the same as A to B plus B to C. So we're going to add these two vectors together. So adding the X changes, -3 plus -2 is -5. And in the Y, -5 plus 1 is -4. So we've actually got the same numbers, but the other way round in our question here. So we're going to get the same magnitude. So we've got -5, -4. So this time we're going 5 left and 4 down, but it makes absolutely no difference to the size of the triangle. So we're still going to get 4 squared plus 5 squared equals h squared, and h is going to be the square root of 41 again. Here is a different question. This time we've been given A to B and C to A, and we want the exact magnitude of B to C. So again, we're going to use the fact that A to B plus B to C is the same as A to C. But this time we're working out B to C. So if we take A to B away from both sides, we get B to C is the same as A to C, take away A to B. And we've been given A to B, but we've got C to A. Now A to C is backwards along this line. So from C to A, we go back 7, down 4. From C to A, we go left 7, down 4. From A to C, we're going right 7 and up 4. We'll go right 7, up 4. So A to C is this but negative. When we go backwards along a line, it's the same but negative. So A to C is 7, 4. So to work out B to C, we're going to do A to C, which is our 7, 4, take away A to B, which is 3, 2. 7 take away 3 is 4. 4 take away 2 is 2. So B to C is 4, 2. So if we did draw a triangle, it would be right 4 up 2. I'm going to go straight to A squared plus B squared equals H squared. I'll quickly sketch it. Right 4 up 2. We want the hypotenuse. So we've got 4 squared plus 2 squared equals H squared. And I'm going to type it in the calculator. So we've got 20. H squared is 20. H is the square root of 20, which is simplified to 2 root 5. So H is the square root of 20, which is the same as 2 times root 5. And a question for you to try. So pause the video and give it a go. So we've got B to A and B to C, and we want the exact magnitude of A to C. So again, I'm going to write A to B plus B to C is A to C. We've got B to C, but we've been given B to A instead of A to B. So A to B is the same as B to A, but negative, but multiplied by negative 1. So 2 and 3. So we've got 2, 3 plus negative 5, 2 equals A to C. 2 plus negative 5 is a negative 3. 3 and 2 make 5. So A to C is negative 3, 5. So if we were to sketch that, it would be left 3, up 5, and again we're working out the hypotenuse. So A squared plus B squared using Pythagoras equals H squared. So 5 squared and 3 squared equals H squared. We'll grab the calculator. 5 squared plus 3 squared is 34, and the square root of 34 is just root 34. H equals square root 34. So that's the magnitude of A to C.